Hello everyone, and let's proceed with this video lecture. We will be starting with this question that I have given as a homework in one of the previous lecture, and this is related to the constraint motion. And this is this we need to find the relation between v1 and v2. That means a constant relation between these two velocities. v1 is given, so finally we need to find v2, which can be easily found out once we find the relation between these two. And the question says the string is tied over there and passes through this ring and then connected to this ring. Thus length of the ring will be remain constant, so that can be one of the constant way. Another could be summation t dot v. So we are going to use the summation t dot v, and let's see how we can find it out. So this is the same string, right? So same string has the same tension at all the points. That's one of the point we have understood. And if we need to draw the tension at this ring, so the tension is going to be along the string in the ring. That's one tension you can see easily. Where is the tension on this ring, that is O dash, will be like this along this string in this branch, as well as along this string in this branch. The another one is almost vertical, and this tension will be T. Similarly, this tension will also be T. Now we can use this coordinate system. That means the usual coordinate system. We can call this as x direction I cap. We can call it as a y direction, that is j cap. That's the usual coordinate system that we follow. And then after we can do the components of these tensions. Like this tension can be made two components, one in the I cap direction, another in the j cap direction. So this will become T cos alpha, because alpha is given to us. Another component will be horizontal, that is T sine alpha. Moreover, if you see this angle is also going to be alpha, alternate angle, right? And this will make two components of this tension, one in the horizontal direction, another in the vertical direction. This horizontal component will come as a T cos alpha, and this will come as a T sine alpha. So what I am doing, I have drawn these tensions and made the components so that these tensions can be written in terms of vectors. Now let's say this is 1, so that's why we are calling it as a v1, and another one is a 2, so that we are calling as a v2, right? So for 1, tension 1, so for 1 we are writing tension 1, so tension 1 as a vector can be write it is going to be equal to this in the minus I cap, this in the j cap, so it's going to be minus T sine alpha I cap plus T is upside, so we can write as a plus this T minus T cos alpha in j cap direction. So that is the tension in the ring O dash. Similarly, can we write the tension in the ring which is O, and this will have a two component as shown clearly there. So this is going to be T sine alpha in the I cap direction plus T cos alpha in the j cap direction. Fine. Similarly, we can also write this v1 vector. So v1 vector is going to be v1 magnitude in minus I cap, minus j cap, it's a downside. Or we can write minus v1 j cap. v2, the way we have assumed, could be written as a v2, that is magnitude in j cap direction. Why we have written this t1, t2, v1, v2, you might be knowing that as a constraint relation, we use summation of t dot v for all the elements equal to 0. Here there are two rings, so we need to apply this for the two rings. So this will be t dot v for the first part, that means t1 dot v1, plus t dot v for the second, that is t2 dot v2 rather. This is equal to 0. Now you know the dot product from the vector. You have learned so far how to perform dot. So I'm performing dot directly, and now you need to do the dot of this t1 with this v1. So you know this j component will be surviving with a minus sign, so it will become minus t minus t cos alpha. It's a value of t1 of the j component into v1. How it is coming? You take this vector, go for the dot product. So I dot j will become 0, z dot j become 1. So that becomes this. Then second part, which is t2 dot v2. So take this t2, take this v2 and go for the dot product. So you're going to get as a t cos alpha into v2. This has to be equal to 0. Right? Now you can take the t common and you can divide the t from both sides because t is getting cancelled out. You can say that. Then this will become v2 cos alpha is equal to 1 minus cos alpha v1. We need to find v2, so v2 came out to be equal to 1 minus cos alpha divided by cos alpha into v1. So that becomes your answer. If you look at the options that were provided to you at that time, so that was in some alpha square by 2 or something like. So you can apply the formula of 1 minus cos alpha as well. So that becomes twice sine square alpha by 2 divided by, this will remain cos alpha as such, this into v1. That will become your answer. So one of the option was this, so you need to mark that option. Idea is again quite simple. Constraint relation goes like this. First find a vector form of tv for all the elements that are involved, sum them off and solve that. Okay, so that's your answer. Now let me give you some hint or solution for this exercise second, the way we have discussed the exercise 1. So this question number 1, you can read it. It says speeder moves passing through a stationary policeman hiding behind a billboard with a motorcycle. This 2 seconds is a delay, that is reaction time of policeman, and that policeman accelerate to maximum speed of this, and this happens in 12 seconds. Later on, the person catches this speeder 1.5 kilometer beyond the billboard. We need to find the speed of a speeder. So you can draw a figure like that. This is let's say this is a this is speeder who is moving with velocity v0, constant velocity, and then a policeman will be chasing this after a certain time duration. So and this will have a 2-second less time as the earlier, and you can say that they are going to be catched over here. So both will be traveling this 1.5 kilometer. And if you want to do this quickly or easily, so another way of doing that could be is drawing the graph. So you can have a graph. That means the graph that we are going to plot is this velocity versus time. So we can use the graphical method as well in order to solve the problems. And sometimes it's good to use. So let's say we are using this for speeder. So speeder is moving with a constant velocity. So that's the velocity with which the speeder is moving. And let's say now we plot the graph of v versus t for this policeman. So policeman is starting not from the 0 but later on, and it accelerates, then attains some velocity, and then maintain that velocity. This is how it's moving, right? And let's say they are being this catching, or this is being catched at this location. So this is the time where the 2 catches. That's what we are thinking of, or we are starting with. You can say that's let's say this time is t. Of course, this is the velocity of speeder. Let's say that is v0. So this velocity v0 we need to find out. However, this velocity, that means the velocity achieved by, maximum velocity achieved by this bike or this policeman has been given as a 150 km per hour. So you can convert this 150 km per hour into meter per second. For that thing, you need to multiply it by 5 by 18. So this will become in meter per second. Why I am writing in meter per second? Because everything has to be written in terms of SI unit. Later on you can convert it. So that will be the maximum velocity which is given to you. Okay, and now we will say that if if it is being catched, that means the displacement covered by the this person and the displacement covered by this spider, both must be equal. That means area under the graph must be equal. So area under this red curve as well as area under this blue curve must be equal. That's what we can say. And that area is also given to us as a 1.5 kilometer. That means 1500 meter. So let's write for the spider. So I'm making now equations. For a speeder, it's going to be V naught into T. So that's total time is T. And this will become equal to total, that is 1500. So that's the first equation. Here two unknowns are there, V naught and T. V naught is something we are looking for. If somebody get us know the value of T, then we will get the value of V naught. Then there's equation for this policeman as well, so that can be write down. So that's at T equal to 0 that we have started with. This was the delay time. That means this policeman started 2 seconds later. And this up to this accelerating time, this was 12 seconds. So basically, if it starts from 0, 12 is there, 2 was there, so that will become 14. Can you think of? And everything is running in second. So can you find the area under this blue graph? So that's a triangular area, then there's a rectangular area. So this triangular area is going to be half base. How much that base is? This much. That's a 12. Into height. How much this height is? That height is this value. Let's consider this value as a V. And we know this value of V, that is this number. So I'm writing it by V. Plus the area of this rectangular portion, that will be a V into this time. This time will be T minus 14. T minus 14. And this also must be equal to 1500 because both are meeting at certain point. So they will have the same displacement. And now you got two equations, the equation 1 and equation 2. If you look carefully, there are two unknowns, only two unknowns. One unknown is V naught, another is T. This V is known to us. Now if you look at the second equation, from the second equation you can find the value of T, of course, and then put the value of T back on the first to get the value of V naught. So find T from here, put T there, find V naught, check your answer, you will get your answer back. Okay, so this graphical method can also be used to solve the questions. Now let's move forward, and question number 2. In this question number 2, it says the position of coordinate of a particle that is confined to move along a straight line is given by this. So that's moving in the x direction, one-dimensional motion. Is measured from a convenient origin, and T is a second. So okay, and said determine the distance. So again you see the distance term is coming, so we need to be careful. Traveled by the particle during the interval 1 to 4 seconds. So first of all you will get velocity. This velocity is going to be dx by dt, and if you perform this dx by dt, then you'll find it's going to be 6t square minus 24, and then 6 differentiation will become 0. Then you need to check whether this velocity becomes 0 somewhere. So velocity is 0. So where the velocity becomes 0, so if v is equal to 0, then you'll find some value of t. You'll get t square is equal to 4. That means t equal to 2. So t equal to 2 is the time at which this velocity becomes 0. That means particle changes its direction, right? And you need to find distance up to 4. So what you need to do, solve this from t equal to 1 to t equal to 2 seconds separately and get whatever the displacement is coming. Then solve from t equal to 2 to t equal to 4 seconds separately. Don't mix them, and find this displacement. One displacement will be positive, another will be negative. Then take the two magnitudes, add the two magnitudes together to get your final answer. So that is question number 2. Now let's talk about the question number 3. This says that the speed of a particle when it is at its greatest height is this. Let's talk about the speed, right? Of its speed when it is at its half the maximum height. The angle of projection we need to find out, and the velocity vector with the horizontal at half of the maximum height is. So we need to find velocity, vector angle at that particular location. Anyway, so let's see what we can do here. This is a projectile motion, of course. So we will say, let's draw the picture first for the question number 3 and then make the equation. So I will draw the picture and make equation, rest you need to perform. So this is a projectile, it will be moving like this, the rough picture. And there are 2 points of concern. One is the maximum height and another is the height which is half of the maximum height, half of the maximum height. So you call it as a capital H. So you will call it as a h by 2. Now what is the velocity at this max height? You know that is u cos theta, right? And what is the velocity at this height? So here this will have 2 components. You can consider 2 components. One is horizontal, another is a vertical. Vertical component you can call it as a Vy, and horizontal component will remain the same, u cos theta, because you know the horizontal component does not change. So we will try to introduce as less as possible variables. That is the total velocity, and horizontal component is u cos theta for this as well. Anyway, so let's proceed. So it is saying something like speed. Let me write this component here, u cos theta. There's no space, so I'm writing here u cos theta so that you remember that horizontal component remains the same, and u cos theta. It says the speed of particle when it is the greatest height. That means this is speed. This is speed. Okay, and this speed is this times of its speed when it is half. So v and this speed are being linked together. Now we can write this magnitude of v. What is the magnitude of v is going to be? Can we say it's going to be under root? Okay, let me write properly. Space is less, so I'm writing in small letters. I hope you are able to see. And this is going to be vh square, vy square, vertical component square, plus u cos theta whole square, because the magnitude of velocity is going to be speed and magnitude of velocity is going to be square sum of the 2 components. This is equal to root 2 by 5 times the velocity as the highest point, that is u cos theta. Now you can think of what to do to make it simpler. U square, this will not be square, u cos theta is the velocity. Now what you need to do, you need to square both the side so that this square root will get eliminated, this square root will get eliminated. Along with this, you need to get one more equation, so that equation can be found using this thing, that another information, that this velocity v by that we are writing is at a height h by 2, right? So we can use the third equation, the vertical direction. So final velocity is vy, that's the square of vy, is equal to initial velocity in the upward direction. You remember the initial velocity in the upward direction, which is u sine theta. So v square is equal to u square and minus y minus, because g is downside, right? Twice g into h. In place of h, we will write capital H by 2. Now that's the second equation, right? And in the second equation, you can place the value of h. You know what the maximum height formula is in terms of u and theta. That's u square sine square theta upon 2g. And then you'll find this will get simplified. Then after we can solve the 2 equations, the equation this and this. When we substitute this vy value back on this, then you'll find u square will get cancelled out from both sides, and it will be a single equation in terms of theta. And after solving that, you can find the theta. That means you can find this angle, that's theta angle of projection. And the second part is asking maximum height. This velocity vector makes angle with the horizontal in the maximum height. That means our interest is to find this angle. That means this velocity with the horizontal. Let's say this angle is alpha. We can find alpha. How we can find this alpha? For that sake, use this formula, tan alpha. Tan alpha is going to be equal to vy component, that means velocity is vertical component, divided by horizontal component, which is u cos theta. Now the second equation, if you remember, that you have just made here, this second equation can be simplified in terms of u and theta. You'll find this will carry u, so u and u will get cancelled out. Alpha will come out in terms of theta. This is how we can find this alpha as well for the angle at the half of the maximum height. So that's a good question. and you can solve till the answer. Okay. Now there's a question number 4 about which we are going to take some hint and solution. So it's a projectile. This velocity of projection is given to you. Angle of projection is given to you. It strikes at 90 degrees. That's a crux point. So how we can use this thing? So I'm going to explain that part. So you will take this velocity is going to be perpendicular to the inclined plane, right? Now since this is perpendicular to this inclined plane, so you can take you can make the two component of this velocity. So one component will be in the horizontal direction like this. Another component of velocity will be in the vertical direction, because it's a two-dimensional motion, so we take the two directions separately. Now you can also make the two components of this, one in the horizontal direction, another in the vertical direction, the way we start with the projectile motion, right? So that's a u cos theta, and this is u sin theta. You know this value of u. As well, you also know the value of this theta, so you can use once you made these two components, so that's a vertical component velocity, that's a horizontal component velocity, and you know this horizontal component velocity does not change, so that's the point. That's a u cos theta. It means you know this value, you know u in theta. Moreover, this is 45, so these angles are going to be 45, so this vy, can we say to make ensure that this is 45 because of this 90 property, so vy must be having the same magnitude, so vy must be equal to u cos theta magnitude wise, so vy should be having magnitude u cos theta. That's a magnitude, right? But direction is downside. So first part we need to find the time of flight, so you can use the very first equation in the vertical direction. So there was equation vy is equal to initial velocity, that's a u sin theta minus gt. Remember this equation. Now here vy has to be substituted. What we are going to substitute vy as? Vy is going to be written as a minus u cos theta. Why we write as a minus u cos theta? Because the direction is downside. That means this is the situation when the particle returns back to the ground. So if we write this plus, so that will be situation of somewhere here. That is not we are interested in, right? So this minus sign has to be placed in. Now this number you know, this number you know, and g you know. From here you can easily find what the t is going to be. Make sense? So this is how you can find the value of t. Next, it is asking the distance between the point of projection and foot of the inclined plane. So where is the foot of the inclined plane? This is the foot of the inclined plane, and we are interested about this distance. What is this distance? Let's say this distance is d that we are looking for. So what we can do is this. This point is going to fall at this point. So if you try to measure this is going to be x distance at any instant, and this vertical is going to be y distance. So we can use the y equation to find the y. So what is the y equation? Y equation is u sin theta, that is given to you, into t that you have calculated, minus half gt square, everything you know. So from here you can get the y value, that means vertical displacement at the point of impact. Moreover, if this is y, then you can say this number can be equal to, because this angle is 45, so these two distances are going to be identical, right? And we need to find d. So can we say this d is going to be equal to the distance of point of projection to foot of this inclined plane is going to be equal to the x minus this y. That is what we are calculating, because if this is a y, so this is also going to be equal to y because of this 45 nature. And or you can say isosceles triangle, right angle triangle. And then you need to find what this x is. So for x you can use this equation for x, which is u cos theta into t. T you have got to know, this u cos theta you have been given already, so from here you can find x. Now let's talk about the question number this fifth. That's also a good question. It says a projectile is thrown from a platform at a height this above the ground with a velocity 20 meters per second. And at what angle should the projectile be thrown to reach the farthest point O vertically below this thing? So if we draw a picture, it's going to be some sort of this. This is vertical height, and this is the ground. That's a horizontal ground. That's a rough picture. And this height is given to us. H is given as a 10 meter. And you are throwing a projectile from here, so we need to find at what angle we should throw it so that it reaches to maximum there. So let's say we are throwing it at an angle some sort of this, and the angle we need to find is at what angle should the projectile be thrown to reach this? So let's say this angle is theta, this is angle theta we are looking for. Or let's say we can name it to any angle for that matter. And this is going to go like this. Okay. So you can call it as a U. That U is also given to us as a 20 meter per second. Let's call this angle by different name. Let's say I'm using the name beta this time. Not to worry, right? So this beta we need to find. Beta is measured from the horizontal direction. And what we want, this point is O and this point is the farthest point. So we want this to be maximum, right? So we want X to be max. As far as you can throw, you need to throw given the U value. So U is the limiting factor. Now, one way of solving is that you make this component horizontal, vertical, and write the X equation, then maximize this X in terms of beta. Or what else you can do is this. That means you can use the concept that you have already gone through or learned, that angle in a projectile motion. It might make our calculation a bit simpler. So let's say we join this. Now this number is fixed. And this point is a fixed, this point is a fixed, and we want this X to be maximum. Can we say when this X is maximum, this length is going to be maximum? Let's say this is point A, this point is B. AB is going to be maximum. So can we say this is the case of R max on an inclined plane? That means on an inclined plane throwing from upside, what is the maximum range? Makes sense? Now let's say this is inclined plane and this is angle of inclination alpha. And we know this entire angle we measure as a theta as per our notation, if you remember. So we are calling this entire angle to be theta. And this is beta. Beta is the angle from the horizontal that we can measure later on. Now, if we got this theta and alpha, then we can find out what this beta is going to be. Of course, because this angle is going to be alpha. So beta will be basically, this is going to be alpha. So can we write beta is going to be basically this... or we can write it as theta minus alpha or something like. Anyway, and my point is you can use this R max calculations, and you know what this R max is. Can you say this R max is going to be equal to, as per the formula, from upside down U square into G into 1 minus sine alpha. Remember that? And you know what this theta is for that maximum range, and theta comes out to be 90, that is pi by 2, and this plus alpha by 2. Remember this? So you can use these directly relations, and moreover, if this alpha, then this R max can also be related with this h. So you can write sine alpha from this triangle. Sine alpha is going to be h, which is given to us, divided by R max. So if you look these two equations carefully, you will be able to solve for this alpha as well as R max. So you can find what this is, length AB, and you can also find what this angle alpha is. Once you are able to find this angle alpha, right, so you can place this value of alpha over here so that you can find the value of theta. Once you are able to find value of theta, you can find the beta or theta, whatever is being asked in the question. So this is another way of doing the same problem, and here we are using this motion of projectile on an inclined plane. Now let's pick the question number next, which is 6. And for this question number 6, we can have the following hint. It says two guns are situated at a height given. So let's say this is a height where the two guns are situated. Let me make a picture over here. So let's say this is a height of the hill that is given to us, and this is the horizontal track, and two firing are being done. One is being at an angle given to you, 60 degree, and so this will have a path like this. Another firing is done horizontally like this, so this will have a path like this, and they collide in the air at this location. So we need to consider this as origin. This has been given as a 10 meter, that is, you can call it as h, which is given to us 10 meter, and this is, let's say, point A from where you are throwing, and this is point B where they are colliding. Now for both the particles you have been given the value u is the same value, this has the same value. This angle is given to us as 60 degree, or theta you can call it for the first, and you can simplify. How we can simplify, and what would be the conditions for this collision? So there are different times taking place, right? So let's say the first was played at t, first took the time t to reach the from A to B. And then second will take a little later time because that's a short later on. So let's say this is t minus t naught. That means the firing has been done after t naught. So second takes t minus t naught time, first takes t time, and then they reaches to the same position. That means you need to find the x for the two, x1 and x2, equate then x1 and x2. Then we need to equate y1 and y2. That means their vertical displacements. That means they will be at the same point. So this will give us two equations. Now, out of these two equations, we need to find two unknowns. And what are the two unknowns? One is a t, another is a t naught. So both unknowns can be solved, and we can find what is t, what is t naught. Now, what is x? How to write x for the first? Let's say this is the first, and this is I'm calling second. So first will have its own equations, the four equations. So x equation for it, then this is y equation for the two. You can write easily and solve. And from there t and t naught can be solved. Our focus will be on t naught, so t naught can be solved. Once you are able to solve this t and t naught, then you can find what is x, what is y. So this is basically x, the final coordinate. This is x basically for the two. This is y for the two. What does that mean by x? X means this displacement. And as per this origin, if you measure the coordinates, so x will be the same as x1 and x2. But y will not be the same as this. So this y that we are going to measure as a coordinate, so you can write x can be written as x1 or x2, but y will be written as this total minus that one y1. So total is h. Out of h we need to subtract this y1. So y1 magnitude has to be subtracted. You will find this y1 will come out to be negative, y2 will come out to be negative. That's why I have placed this in mod. Or you could write it like h plus y1. That's also going to be helpful because y1 is negative. So, or another way of writing is like write the magnitude and subtract it out. So that will be the coordinate of this point, where they are going to hit. So coordinate you are able to find, and time interval you can find from this calculation. I hope this helps you to find the two unknown quantity. Now let's talk about the question number 7 that is there. It says this particle is being thrown at perpendicularly from this point, and it lands at q at perpendicularly. So it goes some sort of this. So it's a projectile motion. Roughly it goes like this. And only this segment we need to study. So what we can do is we can make the components and velocity. This u is known to us. So you need to go like this. This is the horizontal component, and this is the vertical component. So you know this horizontal and vertical because you know this angle 30. So this is going to be 30 and this is going to be 60 degree. Can you think of that 60 degree? Because this is 90 degree entirely and this angle is 30 degrees. So that angle of projection from the horizontal can be thought of 60 degree. So you will get this u cos 60 and this will become u sin 60. So initially, or we can say initial velocity of projection, if you know this initial velocity is of projection, and then at this moment, whenever it's going to strike, we know that this velocity is going to be like this. That's the final velocity of, or velocity of the strike you can call. But you also know that this will have two components. One will be in the horizontal direction, another will be in the vertical direction. This horizontal component will remain unaltered. That's important point that we keep always. So it's going to be u cos 60 degrees. So that means you know this number. Once you know this number, then you can also know this downside number. You can call it as a Vy. How you can know it? Because this is a 60 degree angle. So you'll find this angle is going to be 60 degree by the same rule, and this is at perpendicularly striking. That means this angle is going to be 30 degree. If you're finding this as a 30 degree, then you can apply some equations like this, that this is also going to be equal to V cos 30 and this will be equal to V sin 30. Now V can be calculated. How? By this equation. So you got one equation because u is known to you, cos 60 you know, cos 30 you know. From here you can calculate V. Once you calculate V, then you can calculate this Vy, and now you can answer any of the questions like this. This is to find the time of flight. So to find the time of flight, what you can do, you can use this vertical equation Vy. Vy is equal to initial vertical, which was u sine 60, and minus gt. Now in place of Vy, you need to write as with a minus because the downside, so this could be written as a minus V sine 30 degree. Now you have calculated this V, G you know, U everything is you know. So from here T can be calculated. This is the time of flight, that means time till then this particle was in the air. Similarly, you can answer this B option. This is velocity with which the particle strikes at the plane OB. That's a V, which you have already calculated. Now we can similarly do the next part, and that next part is part C. It says we need to find the height of point H, the point P from O. That is this H we need to find. So we can have this construction. That means we are dropping it down, and this horizontal we are matching. So we need to find this H, right? So for that sake, what we can do is this. Can we find this? Let me use different color for that purpose. So can we use this thing? We can find this value. This value is going to be Y. Using the Y equation, Y is equal to u sine theta t minus half gt square, and t we have calculated from the A part. Moreover, this angle is 60 degree. So since this angle is 60 degree, then we can also find what this is going to be. Let's say this is something called x1. And this x1 can be calculated by using this right angle triangle with angle 60 and this vertical y. Okay. And moreover, let's call it x0 for that matter. And moreover, we can also find this distance, the entire one from here to here. If we are interested in the entire one, so that's a x displacement during time t. So x is equal to u cos theta into t. T we have calculated, so x will be known to us, x0 will be known to us. So by subtracting these two, we can think of what this value is going to be, the value of length from here to here. Now we have calculated this because of a purpose. Now you can see this right angle triangle. This is a right angle triangle because you know this is 60, this is 30, so this has to be 90 degree. In right angle triangle, we know these angles, right? That means this angle is 30, this angle is 60. So we know all the angles, and we know this one side. This side we have calculated, right? This is going to be x minus x0. I'm just giving you an idea. You need to work on this. You will get your answer definitely. Now, once you got this, so in this triangle, we need to find this perpendicular length, that is h. So you can do this. You can get this drop a perpendicular, and you can find this h either of the way, because this is 90 degree, or do whatever you want. Use some trigonometry. You can find this h value. Once you are able to find h, that means C part is done. Then after, you need to find what is the maximum height attained by the particle from this. So maximum height, that means this height. Now for this projectile motion, you just use the formula of maximum height, and that formula can be directly used because you know this is a horizontal projectile, similar to that we are considering. So what will be the total distance of the highest point from vertical distance from this? So vertical distance, the maximum height that you are looking for, is basically h that you have calculated in C part plus capital H, that's maximum height. And then it's asking about the distance PQ, that means distance between P and Q. So this is point Q, this is point P. So we need to find this distance. Can you find this distance? Yes, of course we can find this distance, because we have already calculated this as x, this is a y, so this distance will become under root x square plus y square. So this is going to be under root x square plus y square, and x and y, they can be calculated using the equation of projectile motion. Okay, so this is all for this video, and we will stop here. So you need to resolve all the question till the answer, and then check your answer. And it will be surely helping you to apply the formula and use the concepts that you have learned in order to solve the problem. And the rest of the questions we will be discussing in the upcoming videos. So thank you for watching. Have a great time.